FlexAttention, created by Meta, is an AI research tool that lets researchers create a lot of different attention mechanisms and without sacrificing performance of handwritten kernels, so they are fast. So it's a tool to create quickly, fast, and efficiently, and a lot of different attention mechanisms. This addresses the problem of software lottery, where the feasibility of a new model architecture is dependent on the availability of an existing optimized software kernel, or you need to know how to write it yourself, which is also difficult. So you just need to write a few lines of code in PyTorch to create a new attention mechanism, and it will all be compiled into efficient fused kernels that run fast on GPU. You don't need to know how to write it yourself. This approach not only accelerates the research and development cycle of a single person, but also democratizes the ability to explore novel attention strategies for a lot more people. The key of FlexAttention lies in two key modular components: score mod. This enables modification of attention scores after the query key dot product. And mask mode lets you create different attention masks. For example, Causal Mask for decoder models and sliding window attention. Let's see some code examples. So let's see how to implement Causal Mask. So we use this mask mod to return true if query is greater or equal to the key. So query can only attend to keys that have same or lower index. So query index is greater than key index. So it can only attend to previous tokens, not future tokens. And we will create this block mask, create block mask from our Causal Mask mod just for some optimizations, and then apply FlexAttention with the block mask. Then we have sliding window attention, where queries can attend to just the fixed window of previous keys, previous positions. So let's say last 10 positions, last 100, or last 1000 positions. So the condition here is that, of course, queries can attend only to previous and the same position keys, and only up to a certain size, window size in the past. And the rest of the code is same. Let's see this relative position bias. So this is just gonna modify the attention scores based on the distance between the query and the key tokens. So it will apply penalty if the distance between tokens, the query and key, is longer. Here we will use score mod, not mask mod. This will let us directly manipulate the attention score. The function in this case is called alibi bias score mod. We calculate the distance between the index of query and key, and then the bias is minus distance times this slope, 0.1. And then return the score, the current score plus bias, which will be some negative number. So we subtract a little bit, and the longer the distance, the more we subtract from the score. So this will make it pay less attention to tokens that are further away. Another use case is you can put multiple documents into a single sequence, but you would only let tokens attend tokens in the same document because other documents are unrelated. So you can gain nothing by attending to other documents. You get no information. You just get useful information from the same documents information. So here we want to mask just the current document and have causal attention, so only look at the previous tokens. So we will create separate mask mod functions and combine them with AND operators, so both of them must be true. This is one example. So we do document IDs like this. So first document has these 3 tokens, second document has these 5 tokens, and now we just combine that with our causal mask. You can check this if you want to understand like how it works, but the idea, like I think you get the idea. We just use AND is causal and same document. that would be the quick intro for FlexAttention. You can use many different kinds of masks and score manipulations and design attention mechanisms quickly. So check out other videos on my channel and see you next time.